All right, we're going to review a topic on how to solve inequalities, and namely inequalities that are not linear. So in this problem, we're trying to figure out when is x squared minus 7x plus 6 greater than 0. So we're trying to find all the x's that I would plug in to this inequality, and it would be bigger than 0. So if I put in 1 for x, does it make it bigger than 0? What about 2? What about negative 100? So there'll be lots of numbers that will make this true. We just want to figure out what those are. So to do this, we use what is called a sine chart. So a sine chart, we're going to try to figure out which intervals this is true and which ones it's not. So the first thing I'm going to do is I'm going to try to figure out what would make this 0. Now, we always want to make sure that in these problems we have a 0 on one side, but what we do with this in calculus, that's typically not a problem. It's already going to be that way. So we figure out when this is 0. So this is a quadratic. You could, of course... So we could factor this if we want. So this factors is x minus 6, x minus 1. So this is going to make x 6 or 1. So if I plug in those numbers, I get 0. Okay? I'm trying to figure out which ones will make it bigger than 0. But this is our starting point. We always want to figure out what makes it 0. We generally will call these critical values, especially in calculus and algebra not so much, but the things that make it 0 we're going to call critical values. So now I'll make my sine chart. To make it, I'm going to make a number line. This is just a generic old one-dimensional number line, and I'm going to put my values on there. 1 and 6. You can put them below, above, doesn't matter. So I'm going to do, when I do this, I essentially break my number line into 3 parts. So we'll call this A, B, and C. Now A is going to be all the numbers smaller than 1. So in interval notation, that's negative infinity to 1. Region B is going to be all the numbers in between 1 and 6. So that's 1 and 6. And region C is going to be all the numbers bigger than 6. So that's 6 to infinity. So one or multiple of these regions are going to be the numbers that are going to make this true. So what I do is I'm going to pick a point in each region. I'm going to call this a test point. So I'm going to plug this in. I'm going to pick a point in each region. So I'm going to pick a number that's between 1 and negative infinity. Let's say I pick 0. And then I'm going to pick a number between 1 and 6. I'll pick 5. And then I'll pick a number bigger than 6. I'll pick 10. This could be a lot of different numbers. So now what I want to do is, now that I've picked those numbers, I want to take those test points and I want to plug them in for all the x's. And I do not care what I get. All I care is when I plug in, do I get a positive or a negative number? So if I plug in 0, I get 0 squared minus 7 times 0 plus 6, which is a positive number. That's all I care about, that it's positive or negative. It's positive 6. I don't care. I just care if it's positive or negative. Now if I plug in 5, 5 squared is 25. Minus 35, because 7 times 5 is 35, plus 6. So that is going to be a negative number. I don't care what negative number. Maybe it's negative 4, but I don't really care. I just care if it's negative. And then I'll plug in 10. 10 is going to be 100. Minus 70, plus 6. That is a positive number. Now, I only care if it's positive or negative, because in this problem, this is saying that I want to know when this is greater than 0. Well, it's greater than 0 when it's positive. So the two regions that are going to work for this are going to be region A and region B. So my answer to this problem, my solution, is just going to be those two regions. It is negative infinity to 1, and it is 6 to infinity. So if I pick any number in this region, 1 million, negative 1 million, and I plug it into this equation, it will be true. It will give me a number greater than 0. If I plug any number between 1 and 6, it will be negative, and thus making it false, because in this one, I said greater than or equal, or greater than 0. Now, speaking of that, so this problem is done, 100% done. Now, the only difference can be is if you have an equal sign here. If it's greater than or equal, remember, greater than or equal will produce brackets around the numbers. Okay, so parentheses not equal, brackets mean equal. So if you had that, it would change to this. But besides that, Nothing else changes. So let's look at one more of these. Now, this is a little different. This is a rational inequality. Same kind of concept, except for our critical numbers, we have a top and a bottom. Now, for my critical values, I'm still going to find what makes it 0, but I'm actually going to look at the top and the bottom. So I'll look at what makes the top 0. That would be 4. And if it's the top, we call it a 0. But critical values can also be what makes the bottom 0. Because technically a critical value is anything that makes it 0 or undefined, and making the bottom 0 would be undefined. This would be x equal -2. But instead of being a 0, I'm going to call this an undefined value. Now you could have multiple zeros for the top. These are always on the top. You could have multiple undefined values. These would be on the bottom. But in this one, there's just one of each. And again, we're not trying to do the most complicated ones when we see these, just some basic ones. So I'm going to draw my sine chart. So here's my number. Now I have two numbers in this case. I will put -2 first and 4 second because it goes in order. Put my dashed lines. So my three regions in this case are -infinity to -2, -2 to 4, and then 4 to infinity. Now I want to be careful because remember, this 4 is a 0 and this -2 is an undefined value. Now before it didn't matter when it's a polynomial, when there's no undefined values, it doesn't matter, they're all zeros. But if there's a difference, it is a good idea to put that on there, and I'll show you here in a bit why. So I'm going to pick a test point. So I'm going to pick a number less than -2. How about -10? And then I'll put one between -2 and 4. I'll pick 0. And then one bigger than 4. I'll pick 10. And then we're going to plug it in to see if it's positive or negative. So I'm plugging it into my expression here. So -10 minus 4 is -14. Divided by -10 plus 8 is -8. That's a negative divided by a negative, so that region is positive. If I put in 0, I get -4 over +2. That is negative. And if I put in 10, I get 6 over 12, which is positive. Again, don't really care what the number is. I just care if it's negative or positive. Now, in this case, we're looking for greater than or equal to 0. So that is going to be the two ends again. It certainly could be the middle. It just happens to be the ends in this case. So my answer is going to be those two regions. So it's going to be -infinity to -2. Now in this case, we have to be a little careful because it is equal in this case. So I should use brackets. But the problem is you never use brackets for an undefined value. You can use brackets for a 0 when it's equal. So there should definitely be a bracket on 4. But since -2 is undefined, I can't equal -2. So I just leave it with a parenthesis. So the values that would make this true are all the values from -infinity to -2, but not counting -2 because -2 is undefined, so obviously I don't want to use it. And then any number including 4 or bigger, if I plugged it in, it would make this inequality positive, thus true. So you have a couple problems to try for your assignment this week, so let me know if you have any questions on how these work.